13.5, solving trig equations. So let's go over this worksheet. So first one, draw triangles and quadrants that satisfy the given condition. So this is all about all students take calculus. Remember the way this works? Everything in quadrant 1 is positive, all trig functions are positive in quadrant 1, and then it's all about what trig function you're doing. Sine, tan, or cosine will be positive in the corresponding parts. So cosine, so all students take calculus. Cosine will be positive at A and positive at C, and negative at these two. My value is positive, so my triangle should be in quadrant 1 and quadrant 4. Cosine's negative, so right, cosine's positive in these two and negative in these two, so it'll be these guys. Sine, if I do all students take calculus, sine is positive at A and S, and then negative at T and C. I have a negative sign, so that should be in quadrant 3 and quadrant 4. There's some bad triangles. Tan, TOA, so all students take calculus. Tan is positive at here and here, and negative here and here. Right, quadrant 1 because of A, quadrant 3 because of T. So your triangle should be in quadrant 1 and 3 because we have the positive. So that's the general idea. So now let's use that to actually solve things. So solve these trig equations for 0 to 2 pi. So sine of x equals 1/2. I draw a triangle, all students take calculus. I know it can be up here in quadrant 1. That's a terrible triangle. In quadrant 2. Like that. Then I go, okay, what does sine tell me? Sine is so opposite of hypotenuse. So that means my opposite should be 1, my hypotenuse should be 2. And just from that, I show what type of triangle this is, right? We have 30, 60, we have all these triangles. 30 is 1, 2, rad 3. 60 is rad 3, 1, 2. And then 45 is the 1, 1, rad 2. So just based off of this alone, opposite 1 is 30. So I have 30 degrees. This is 180. So you're 30 before that, which would be 150. Or if we want in radians, 30 degrees is pi over 6. This would be 6 over 6. So 1 less would be 5 pi over 6. So any way you want to answer it. 30 degrees, 150 degrees. Or if I want to do in radians, it would be pi over 6 and then 5 pi over 6. Next one. Tan is negative. So all students take calculus. Remember, tan is positive at T for tan and then A. So it must be negative at these two. Again, it's all about figuring out what triangle we're talking about. So tan is TOA, so opposite of adjacent. My opposite should be -1, my adjacent should be rad 3. And again, just from that, I show what type of, wrong spot. I just know what type of triangle that is. Opposite the 1 is 30 degrees, so we have another 30 and 30. Now the angle is different. This one right here, we're going from here all the way to there. So this is 180, and you go 30 back, so 150. This one is 180, 360, and you go 30 back, so 330. So those are my answers, 150 and 330. If I wanted these in radians, to me radians are actually a little easier. As long as you know that 30 is pi over 6, pi over 6. This is pi, so it's 6 over 6. So this would be 5 pi over 6. Then you go around again, it'll be 12 pi over 6. And then a little bit before that is 11 pi over 6. So for me, radians are actually a little easier because I just have to subtract 1 plus or minus 1. Or the other one I gotta do like 30, 60, 45. Okay, a little more advanced. So this one's not solved first, we gotta solve it ourselves. So subtract 1, a little algebra first. Divide by 2. So I got cosine equals -1/2. All students take calculus. Cosine is positive at C and at A. C stands for cosine. But I want negative, so I'm going to be in these two quadrants. And then again, what does cosine mean? So adjacent or hypotenuse. So the adjacent side's 1, -1, and the hypotenuse is 2. Cosine is my least favorite by far, because all the rest, like we did the ones up here, once you have the side, you know what angle it is, because it's right across, right? Same thing with tan. Cosine, you don't have that. You have the adjacent. That doesn't tell you what angle it is. You got to think an extra step of going, okay, what's missing? I have 1, -1, I have 2. What's missing is rad 3. We don't have a rad 3 in. It's a 1 rad 3, 2 triangle. So this is 60. So that's a 60-degree angle right there. So this would be 180 minus 60. I can go back 60, so 120. And this would be 180 plus 60, so 240. So 120 and 240. If you want to do radians, you just gotta know that 60 is pi over 3. So this would be 3 pi over 3. And then one less would be 2 pi over 3. And one more would be 4 pi over 3. So there you go. Next one, 3x plus 1 equals 4. So again, just solve it first. Let's do some algebra. 3 sine of x equals 3 divided by 3 sine of x equals 1. So now it's a special one. Sine of x equals 1. I've talked about this before, but that's a quadrantal angle. If you didn't know that, like a lot of people don't know, they'll do this, which is a good trick. Sine will be opposite of hypotenuse, but you have a problem here. There's no triangle with the 1 and the hypotenuse. Well, there could be, but you can't have a triangle with the hypotenuse of 1 and a side of 1 that's a right triangle. So it doesn't work. So that should be red flags. What this is a quadrantal angle. Right? Anytime you get plus or minus 1 or 0 for sine and cosine, it's a little different for tan. Tan could do it, but sine and cosine can't. It's a quadrantal angle. It's a unicircle. It's one of these guys. So you just gotta remember all the sides are. So remember, it's like a normal XY chart. So go this way, 1, 0. You go up, let's say pi over 2. That'd be 0, 1. You go left, pi, which would be negative 1, 0. And you go down, 3 pi over 2. 0, negative 1. This would be 2 pi. Right, it's like a normal XY chart. You go to the right, you move your X. You go up, you move your Y. You go left, you move your X. Blah, 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 blah. Next step. It's that sine equals 1. So where's sine? Sine x for y. Sine e, sine's the y value. Look at all their y values. Where does sine equal 1 at? Right here, pi over 2. That's the answer. Next one, it's like 2 problems in 1. Lucky for us. So the first step we're gonna do is like any algebra problem, you split it. You get 2 sine of x plus rad 3 equals 0. And you get cosine of x minus 5 equals 0. So on this side, we'll do this side first, it's a little easier. Cosine of x equals 5. Red flag right there. Cosine is sine, it's a unit circle. Can't be more than 1 or less than negative 1. So this is no solution. Sine and cosine have to be less than or equal to 1. It has to be between 1 and negative 1. Can't be anything bigger or anything lower. So if it gets like this, no solution. Over here though, we could solve this. Subtract the rad 3. Divide by 2, and you get that, and then we just gotta solve it like normal. It's like we've been solving it. So all students, this is a negative, so I'm gonna be down here. Right, sine, all students take calculus. Sine's positive at A and S, but we have a negative sign, so here and here. Right, sine's the y value, so it's negative where the y values are negative at the bottom. Cosine's the x value, so it's positive where the cosine, where it's positive, where x's are positive and negative, or x is negative. So that's just the way it works. So sine's just the y's, cosine's just the x's. So I know when it's negative, it's going to be down here for sine. And then sine is SOHCAHTOA, opposite of hypotenuse. So opposite's rad 3, hypotenuse is 2. And this is why sine's my favorite, because I already know. I know the opposite side is rad 3. This must be 60. So it tells you right away. So if this is 180, you're going to go plus 60. So I get 240. And then this, you have to go all the way around to 360. And then you go back 60, so 300. And again, if you're doing radians, the trick is it's pi over 3. It's 60 is pi over 3. So this would be 3 over 3. And you go one more, so it'll be 4 pi over 3. Then on this side, it'll be 6 over 3, 2 pi. 6 over 3 is 2. So one less would be 5 pi over 3. And there we go. Let's do some more of these. So same idea, we got to split it. Cosine of x equals plus 1 equals 0. Sorry about that. I was trying to decide if I wanted to shortcut it. There we go. And then sine of x equals 0. I'll just solve this real quick. You'll see why in a second. There we go. So you have these two. Sine of x equals 0, cosine of x equals negative 1. So these are both unicircle problems, right? Anytime sine or cosine equals 1 or negative 1, it's a unicircle. So I'm just draw a unicircle real quick like we did earlier. 1, 0, 0, negative 1, positive 1, I don't know what I was thinking, positive 1, negative 1, 0, and then 0, negative 1. This is 0, this is pi over 2, this is pi, 3 pi over 2, and 2 pi. So then, just like before, sine e, sine's a y value, so where does y equals 0 at? It looks like it's here and here. So 0, pi, and 2 pi. 0 range. See, 2 pi is included, so we'll count it. It does have equal to. And then where does cosine equal negative 1 at? Well, cosine is the x value, so that only happens right here. So it's at pi, which we already have. So this is my answer. Alright, so I get from when the sine equals 0 at, I get 0, pi, and 2 pi. And then I get where does cosine equal negative 1 at? That happens at pi, so that's my answer. Next one, split 2 sine of x plus 6 equals 0, and then tan of x plus rad 3 equals 0. Solve it, subtract 6, 2 sine of x equals negative 6, divide by 2, sine of x equals negative 3, tan of x equals negative rad 3. Now, remember I said earlier, if sine and cosine is bigger than or less than 1, no solution, so this is not possible. I just gotta solve this guy. Tan you always want to put over 1. It's TOA. So where is tan negative? All students take calculus. Tan is positive at 1 and 3, so it must be negative at 2 and 4. Like that. TOA, so opposite's negative rad 3. Adjacent's 1. And much like sine, tan tells us right away what angle we're talking about, right? Opposite's rad 3, I know it has to be 60. So then, just go to 60 there. So here's 180, so 60 less is 120. Once you do a lot of these, there's only so many answers. You can just kind of get used to it. Over here, this is 0, 360. Subtract 60, so 300. So there we go. Again, if I want to do radians, this would be 3 over 3. So 1 less would be 2 pi over 3. Going a little faster now. Over here would be 3 over 3, so 6 over 3. 1 less would be 5 pi over 3. So there we go. Oh, now we're another level. So these are not even factored for you. You got to factor ourselves. So we got to do a little math first. So a couple ways to do this one. I'm going to solve it like a math problem. I'm going to add 1 equals 1 divided by 4. And then I gotta get rid of the square, so I'm gonna square root it. Now keep in mind it's an algebra problem, so when you square something you have to get plus and minus. Square root of 1 is 1, square root of 4 is 2. So square root of both sides, I get plus and minus. Square root of 1, it happens to be 1, square root of 4 happens to be 2. What does it happen to be? It's mathematically correct. But anyway, so we're gonna get, so how do I do this? Well, if you do all students take calculus, right, it's where's sine positive, A and T, whoops, A and S, sorry, and then where's sine negative, T and C. Like essentially you're gonna get, every quadrant gets to play. We're gonna get 4 answers. We're gonna get the positive answers and negative answers. So let's just do them real quick. Once I get one, triangle, no low rest. So I didn't try my hardest to draw them all nicely. So sine is so. Opposite of hypotenuse. So opposite's 1, hypotenuse is 2. With that, again, sine's my favorite. It lets you know if I know opposite's 1. There's actually only 2 options when one of the sides is 1, but it's 1, 2. That's a 30-69 triangle. Right? 1 rad 3 2. If it was 45, it would be a rad 2. So this one, it's a 30-degree triangle. So 30, they're all 30. So this is 30 away. If this is 0, you go 30 up, so you get 30. This is 180, right? This is 30, so you go 30 back, so 150. You go 30 forward, so 210. And then this will be also 360. You go around a full circle, and then 30 back is 330. So those are my 4 answers. 30, 150, 210, and 330. If I was doing radians, you just gotta remember 30 is pi over 6. This would be pi over 6. This would be 6 over 6, so 1 less would be 5 pi over 6. 1 more would be 7 pi over 6. And then If I get over here, right, this one, you gotta go, this is 6 over 6, go all the way around, 12 over 6, and 1 less will be 11 pi over 6. So those will be the 4 answers, either in degrees or in radians. Next one. So this one, you actually got a factor. There's 2 signs there. It's like they both have a sign. We can factor that out. Sine of theta equals sine of theta minus 1. Right? Because there's 2 signs. So you took one out. There's still one left over. And then took the sign out, so it's only a 1. Split it. Sine of theta equals 0. Sine of theta minus 1 equals 0. So sine of theta equals 1. So you got to solve both of those things. Good old algebra. Notice it's 0 and 1 for sine, so that means it's a unicircle one. It's one of these points here. Alright, so it's either 1, 0, 0, 1, negative 1, 0, 0, negative 1. Sine is the y value. So we're assigned 0 here and here, and we're assigned 1 at here. So answers are 0, pi over 2, pi, and 2 pi. There we go. Next one, cosine minus 2 cosine sine theta. So again, we want to factor it. Notice they both have a cosine, so we can factor out the cosine. We're left with 1 minus 2 sine theta equals 0. Split it, cosine theta equals 0. 1 minus 2 sine theta equals 0. This is some algebra. If I add the 2 sine on both sides, I get this. Then divide by 2. So sine side effect. Right, just some good old algebra. Cosine equals 0. Unicircle again. Do a little short one right here. Right. 1, 0, 0, 1, negative 1, 0, 0, negative 1. Cosine's the x value, so it's here and here. That would be pi over 2. And 3 pi over 2. Where does sine equal 1/2? I actually gotta draw that one. So, oops, all students taking jump in again. Takes calculus, so it's positive here and here. Right, and then it's sine, so opposite right hypotenuse, so 1, 2, 1, 2. If you've done this enough, you kind of start having memorized. What's opposite 1? 30 degrees. So this would be 30. This is 180. That kind of looks like a 50. This is 180, and then 30 less would be 150. If I want radians, that'd be pi over 6. And then this would be 6 over 6, so 1 less would be 5 pi over 6. So here, I had it over here, here, and here. So those are my answers. Next one, sine of 2 theta minus cosine. Now, if you look at the key already, I did this one. We actually, this is a double angle formula. Which we didn't have to learn this year because we had to suspend classes because of COVID. So we actually skipped that lesson. So this one won't be on the quiz or test this year. But if you're curious how I do, I'll just do it real quick in case I use this video in the future. Sine 2x there's a formula for that, which is 2 sine cosine. It's a double angle formula. There's a whole reason why it works. So it's going to be 2 sine cosine. So again, not going to be on anything this year. Equals 0, factor out cosine. 2 sine theta minus 1 equals 0. Split it. Where does cosine equal 0? Luckily, we just did that right here. So pi over 2 and 3 pi over 2. No work needed. And then this is sine theta equals 1/2, which we just did right here. So pi over 6, 5 pi over 6. But that's how you get there. So that's a double angle formula, which we haven't learned this particular year, but normally you would, and that's how you use it. That just means 2 sine cosine, you plug it in. More tricky equations. Oops. Solve these equations for that. So we're going to take an extra step. So if you look at this first one here, it's not even set equal to 0 first, so I got to do that first. So I'm set equal to 0. So let's move all the, if it helps, I've said this before, but just ignore the signs and just put x's there. So substitution, right? Just solve it like that. So how do I solve that? Set equal to 0. So I move all this stuff over to that side. Subtract 3x, subtract 2. And then what do I do next? I have to factor this. So I have to multiply these two together. Find two things that multiply to get negative 4, but I have to get negative 3. So negative 4x and 1x. Sub it in for the middle. 2x squared minus 4x plus 1x minus 2. These have a 2x in common. Always bring down the middle sign. These have nothing in common, so we'll pull out the 1. These factor. I still have the 2x plus 1's left over. Pull those out. So that's all factored. Now I just got to go back and put my sign in. So it's going to be sine of x, minus, or theta, but I'll leave it x for now. And 2 sine of x plus 1 equals 0. Split. Sine of x equals 2. And then sine of x equals negative 1/2. Sine of x equals 2. Too big. Remember, sine going to be between negative 1 and 1. So this is no solution. Sine of x equals negative 1/2. I can actually do that really quick down here. Remember, sine's positive, sine's negative here, so sine's positive at a and s, so it's negative must be on the bottom two. I love sine, right? Opposites negative 1 and 2. That's a 30-degree triangle. So 30 degrees, 30 degrees. So I'm going to only do range for this one. Here's pi. Since it's 30, it's going to be over 6 over 6. One more will be 7 pi over 6. Move it over, 12 pi over 6. One less will be 11 pi over 6. So like that. So that's my answer to A, which bled into my B here. So that's A. B, try to save some space up here. Look at it. What do they have in common? A tan. So factor out the tan. Tan of theta, sine of theta minus 1 equals 0. Split it. So I have tan theta equals 0. And then sine of theta minus 1 equals 0. So if I solve it, sine of theta equals 1. So remember, sine and cosine are 1 or negative 1 or 0. It's a unit circle. Tan's a little iffier, but if tan equals 0, it's definitely a unit circle. 0 undefined. So it's just a new unit circle. I'll list the things out first, which I should always do. So this would be 1, 0, 0, 1, negative 1, 0. I almost messed that one up. 0, negative 1. Sine 1 is easy. Sine's a y value. Where does y value equal 1 at? Pi over 2. Alright, so that's where the y value is 1. Tan we haven't talked about yet. So how do I do tan? Remember what tan is. Tan is sine x over cosine x. Y. So sine x over cosine x, sorry. Sine e, sine's a y value. So essentially we're just looking for y over x equal to 0 over 1. So basically, when does the y value equal 0? That's all that's going on. Tan is sine over cosine. Sine is y, cosine is x. So when does y over x equal 0? Which really just means when does y equal 0? That's all I'm looking for. Where does y equal 0? So y equals 0 is here and here. So my answers are 0, pi over 2 from the sine, pi, and 2 pi. That's how that problem goes. Again, tan's a little funky. We haven't done it in a while. We haven't done it, especially on a unit circle. Tan's a fraction. It's sine over cosine. And then don't forget sine is y, cosine is x. And all you care about when you do a fraction, when you're looking for 0, is when the top is 0. So when does y equal 0? That happens here and here. The y values are 0. Okay, next one. Sine squared plus cosine 2 theta. So it's another double angle formula. So again, we won't have this year. This time I'm going to skip it to save time. D. Let's make sure I have more. So let's do D here. So it's another. Notice that's not equal to 0, so I gotta do that first because it's squared. Like if you're not sure, I always think it's helpful you just pretend it's x squared instead of sine or cosine. So we have this. How would I solve this? Set equal to 0. Add x to both sides. So I get 2x squared plus x equals 0. Factor out the x. So I get like that. Now I can go back and plug my cosine in. So cosine of theta, 2 cosine theta plus 1 equals 0. Split cosine theta equals 0. 2 cosine theta plus 1 equals 0. So 2 cosine theta equals negative 1. Cosine theta equals negative 1/2. So right here I have cosine theta equals 0. That's a unit circle. So where does cosine equal 0? Where's your x 0? You got 1, 0. 0, 1, negative 1, 0, 0, negative 1. Here and here, that would be pi over 2 for the top, 3 pi over 2 for the bottom. We're just cosine equal negative 1/2. So I'll do this one all the way out. Right, so I was going to say calculus, cosine will be positive at A because everything's positive at A, and at C because C stands for cosine. So it must be negative at these two. Cosine is my least favorite because, so my adjacent for hypotenuse, so adjacent to negative 1 hypotenuse is 2. I gotta know what the missing side is. In this case, it's a negative 1 rad 3 2 triangle. So this is a rad 3, which means it's a 60-degree triangle. Again, if I was doing degrees, it would just be this is 0, this is 180. So 60 less to get here, right? Minus 60, go back, be 120. And then to get down here, you have to go an extra 60. So 240. If I wanted radians to match my answers over here, just go, okay, what's 60? It's pi over 3. So 3 over 3. 1 less would be 2 pi over 3. And then 1 more would be 4 pi over 3. And those will be my answers. Okay, last couple. So right here, cosine squared theta plus 3 cosine theta equals negative 2. So same way, let's add the 2 over. So I'm going to get cosine squared theta plus 3 cosine theta plus 2. And like I always say, I think it's helpful if you just ignore the cosines. Pretend it's an x. So all I gotta do here is factor. What two things multiply to get 2? But I have to get 3. It's only really one choice. That's 2 and 1, and that does work. So it'd be x plus 2, x plus 1. Alright, I didn't need to do the fancy way because there's no number in front. Coefficient's 1, so I can just do the basic, hey, what two things multiply to get this, but I have to get that. So now I factored it, put my cosine back in. Split it. Cosine theta plus 2 equals 0. Cosine theta plus 1 equals 0. Cosine theta equals negative 2. Cosine theta equals negative 1. So we have this. And then cosine right here, way too big, way too small actually, right? Cosine is sine cone between negative 1 and 1. This is too small, no solution. Here, cosine equals negative 1, that's a unit circle problem. Remember, anytime sine or cosine is negative 1, positive 1, it's a unit circle problem. So 1, 0, 0, negative 1, positive 1, always do that. Negative 1, 0, 0, negative 1. So cosine's the x value, so right here, which would be pi. That's our answer. Cosine 2x. Now you might be thinking, oh, that's a double angle formula. Yes, it could be, but actually, when there's a number here, what we do is ignore it till the end. Fancier math people than me call this a u sub. What does that mean? You sub something in for that. You say like u equals 2 theta. So you go, okay, here's a u equals 1/2, like that. So you say, okay, u equals 2 theta. Then we're just gonna solve it. We're gonna solve it like normal. At the end, we'll go back and plug our u in. I just say it's kind of ignore it till the end. So how would I solve this? Well, where does cosine equal 1/2 at? It's positive, so it must be quadrant 1 and quadrant 4. So draw it. Right, it's cosine, my arch enemy. So adjacent to my hypotenuse is 2, which means I gotta find the missing side, which would be rad 3. So that lets me know that this is 60. So if I was doing degrees, my answer would be 60 degrees. And I gotta go all the way around. So 0, 360. That's subtract, and then you have to go. You haven't got the 360 yet, right? We're like 60 short. So subtract 360. Subtract 60, and you get 300. So it'll be 60 and 300 in degrees. So normally I'll be done, right? Like you're like, yeah, that's my answer. But remember, we ignored the 2 theta, or we did a u sub for 2 theta. Now we gotta go back, plug it back in. So all I did was find out what 2 theta equals. 2 theta equals 60 and 360. So how do I solve this? Well, it's divide by 2. So theta equals 30 and 150. Now we have to worry about the domain later. We'll cover that more next year, where like how it does change the domain. You might have to get more answers or get less answers, but for now, we're just gonna focus on how to do this process. By the way, if you wanted radians, right? So this is 60 is sitting the same pi over 3. So this would be 3 over 3. Then you go around again, it'll be 6 pi over 3, which will be 5 pi over 3, one less. So it's the same idea. You get 2 theta equals pi over 3 and 5 pi over 3. Now I don't like dividing when there's fractions involved, so what I do instead is I just multiply by the reciprocal, 1/2. So I get theta equals pi over 6 and 5 pi over 6. So that's the idea. That's it. We are done.